Uh-oh. So here's what we've got rolling here. When we're going to graph these radicals, and we're just going to do the square roots. We're not going to get into the crazier ones here. But you may notice when you look over on this graph that I've got some points that are labeled in here already. Now, there's significance to the specific ones that we've got on here. And you might see in a second where they come from, but I'm just going to label them for a second here. And then we'll see if we can figure out why these particular ones have some interest. Now, if you know anything about perfect squares, you may be able to notice something about this. Let me write down the y values of all of them first. But then when we go to the x's, you may notice that those just happen to be some of the perfect squares that we've talked about before. Because the square root of 9, okay, and I'll talk about this in a minute, would be 3. The square root of 4 would be 2. So basically, what this graph is doing is, it's saying, if I take the square root of the x value, I get the y value. The square root of 9 is 3. If I kept going, I'd get to another point, 16,4. And I'd see all these things happening. So this is my base graph. These are my base points. And we'll get into how that can help me to even do this without a calculator when we get a little bit further. So trying to figure out these parts can get a little bit complex. You look at this and you're like, oh, y equals the square root of x minus h plus k. What in the heck are you doing here? It's bad enough when there's like one variable. Now there's like 4. So what we're going to be doing, okie dokie. So whatever's under the square root, this h value, is going to figure out if we're going right or left. We're going to like start shifting these around and moving them around. And any value that's outside, so this is my h, and any value on the outside here where it's not under the radical anymore is my k value, and that's going to help me to figure out if I'm going to move these up or down. And understanding these shifts actually is more important than the graphing even, because the calculator can do a lot of this for us with the actual pictures. So when you'd move on from this class into the next algebra class, that's something we'd expect that you'd know. So for instance here, I notice the plus 5 is under the radical. Okay, it's under the square root. And then I look at the signs, and it's kind of strange, because most of the time when you go to draw something, you would think, well, to the right's where positives values are. You know, why does it work this way? Well, because the formula says it's minus that, which means it's the opposite. So the opposite of plus 5 would be minus, which means we're going to go left 5. And if I wasn't sure of that, here's where the calculator might be able to help us out a little bit. I could type it in, and to get the square root, and we'll mark this in here too, if I type in second and x squared, that's going to get me the square root. That's kind of important to be able to get with these. And I can just type in, if all of it's underneath, I'll just put all of it in parentheses, the x plus 5, and you'll notice when you graph it, that graph that we saw up above is shifted to the left, and shifted to the left 5 places. So I can get a visual picture of what's going on here. Now, I wouldn't say go to the graphing calculator every time, but it's something I can think about. On the next one, though, you might notice, now my number's not under the square root, it's after it. So now if it's outside, that determines whether we're going to be going up or down. So this particular one goes down 7 because of the negative. Now, if you're going to check on the calculator, you just want to feel comfortable with it, I can get that. Here's the one difference, and I got to be careful because how I type it in is going to make a difference to what the calculator shows me. This time, I just want the x underneath. So notice I closed the parentheses already. And then I'm just going to put the minus 7 after it. That's different than if I put it all in the parentheses. And I go to graph it, and I notice it moved down that many. So I can always get that reassurance if I'm not sure using the calculator to see what direction it's going to go. But it won't always just be one movement. You might get several. But the big thing to remember is whatever's inside, we think the opposite. So a minus on the inside is a right shift, and a plus or minus on the outside is always my up or down. And that may be a little trickier to see if I decided I was going to double check myself on this one. So I'll swing over. We'll take a look at one of these. I won't do it on all of them. But if I was going to graph this, the x and the minus 1 would be in my parentheses, because they're under the radical, all of them are. And then the plus 2 is on the outside. And if I looked at the graph, I would notice it moved right and it moved up. And so I see I did the right thing here. I made the correct guess based on what I saw. So with that in mind, what do you think the two shifts are for number 2? Right and down. Perfect. Right 3. That minus will tell me right, and then the minus on the outside tells me down. One more up here. Let's do 3, and then we'll kind of start seeing a little more what's going on. All right?
So then, like, when it has a negative in front of it, not like that.
Where you want to do it?
Like number 2, when it says -2.
No, the minus and plus numbers are just telling you what direction. I don't have to put the minus sign with it. Good question. That's an excellent question. But nope, it'll always be just plain old numbers we're putting there. So on 3, what directions are we going to be going 4 and 3? Left 4, down 3. Opposite and opposite, okay? Especially when you've got this to work with, not a bad deal. Nothing that's going to work too terribly awful. So now what I want to do is actually get you into, well, how can I graph these? How am I going to get these where I can put them on a graph if you ask me to, which I'm going to. So when we flip over, if I do a square root or even a cubed root, but we're mainly going to focus on the square ones, they're what are called a radical function. Square root's called a radical. So when we're graphing these, and I wrote it again on here, it's second and x squared to get the square root, and then we got to be careful on when we close the parentheses with stuff. So here's how this is going to work. When we get this original one, what we're going to do is we're going to go ahead and we're going to get it typed in just like we see there. I'm just going to close the parenthesis to let things know that that's set and situated. Now, here's the part that gets a little more interesting. If I graph it, you're going to say, well, we already looked at this one on the front. I agree with you. But here's what I want to do. To see where the points are, we're going to hit second and graph, and they're going to give me a table. Now, what I want to do is I just want to use the whole numbers. I don't want to use all these decimals. That's no good. So I see, okay, 0, 0 is whole numbers. So is 1, 1. Then I got to go down a couple. 4, 2. And what I normally will do is I'll check all the way up to 10 because you notice my graph goes to 10 in all directions. So looks like I got about 4 of them. So I'm going to plot those 4 points. 1, 1, 4, 2, because again, this is my x and this is my y. And then 9, 3. And then I just connect the dots. And those are going to be my base for values that I use every time I have a square root function. And then we can just move them from there, but we'll get to that. The other part that goes along with this, besides just graphing it, like I said, the calculator can help us, is figuring out this thing called domain and range. Domain is what are my possible x values. And I start with the one on the left, and I work to whatever's on the right. So I look, my furthest number to the left on my x's looks to be 0. But you're like, well, is my farthest one to the right 9? Well, what's this arrow mean? It means if I kept going, this is going to keep going and going and going forever to the right. So to signify that, we use this sideways 8 looking thing called infinity because it's going to go forever. It's never going to stop. My x's will go and go and go and go. If I popped the calculator back open to that chart and kept arrowing down, I'd never stop. Those numbers are going to keep going. I could be doing this tomorrow and nonstop until you get here then, and it's still going to be going. So that's why we put the infinity symbol to say we don't want to write every single one of those numbers. We need a shortcut. Range is going to work the same way. Whatever my lowest y value is, which in this case again is at 0, until it goes up. And just like the x's, this is going to keep growing upward as it keeps going to the right. So similar to my domain, my range is also, in this case, going to be from 0 to infinity. But that can change as our graph moves. And we're going to get to see that. But we're also going to see how there's a pattern that develops here. So when I get to graphing these, we're always going to type it into the calculator like we did the last one, and then we're going to use our table to find good whole number points whenever we can. So like for instance here, get my square root. I notice the x and the 1 are both inside the radical, so they got to be in the parentheses. And then the -3 goes on the outside of that. So I'm going to look for a couple of things here. Looks like if I was going to look at shifts, it would be left 1 and down 3. So I'm just going to look at the picture for a minute. Okay, left and down, okay. And then I'm going to hit my second graph to look at the table. Now I got to get back up to normal range here. My infinity example got us a little out of whack here. Okay, so I take a peek. Now before we started at 0, you're like, yeah, I'm going to start back here. You're like, ooh, error. What's error mean? Error means my graph isn't even over there. So I'm going to always look to see where those errors start. And my good points, and I'm going to make a little chart out of this, I'm going to start right after the error messages begin. Because now that it shifts, it may not always be 0 where it starts. So I'm like, okay. Now sometimes I may get more values. Oops, there's one that works. And I like the whole number ones when I can. If I don't get those as an option, I'd have to use some of the decimals, but I don't like using the decimals. Okay, most of the time I'll get 3 or 4 points. And once I jot those down, I'm going to graph those. And we'll talk a little bit more about, oops, what those error messages mean. Because here's basically what's going on with those error messages. My graph starts exactly where I had this value, okay? My domain and range are always going to start at wherever that first point is. So if I can find where it says error and look right after it, my domain will start at that x value, at -1. But it'll go on forever, just like it did before. My y value, at that exact same point, will tell me where to start my range and go on forever. You're like, hey, there's kind of like a correlation here. I went left 1, which would be -1 for x. I went down 3, which would be -3 for y. Couldn't I really figure out the domain and range without even graphing it? You could. But this is a nice backup plan if you're not sure on something. You're like, this is kind of strange. It kind of is. I'm going to go past number 2 for just a second. There's a special case in it I don't want to hit quite yet. I want to do number 3 first. So I look at number 3. I go, okay. Ooh, this is a little different. I got a number in front now. No biggie to us. So I'll put that in. Put my 2 in first. And then get my radical going. So x plus 1. Close it, because that's the end of what's inside. And then I'm going to go ahead and I'm going to use the table to help me. And I see the error messages starting already. So my good points are at -1, 3. which again makes sense because what happened with my shifts? I went left 1, which would be -1 on my x-axis, and I went up 3, which would be +3 on my y. So I'm looking for my whole number points because I like those. See how many I find this time. Okay, I found 4 again. That's good. Again, we're just looking between -10 and 10, where we're at on the graph. And then I just plot my points. And I notice my graph's a little wider this time, and that's because of the number that's in front. Makes things a little bit bigger. But again, I should be able to figure out my domain and range before I ever graph it. Because as soon as I see, ooh, the left 1 means my domain is going to shift left 1 from 0. It's at -1. My range went up 3. So it starts at 3 and goes up. And I can start to see how this works out. Now the only other really twist I can throw at you, because again, the calculator is always going to tell you where your domain and range are starting. Right after that error. Whatever numbers are there, there's your domain x value, there's your range y value. And everything's going to be going off to infinity. The only other twist I can throw at you, if I swing over here, and I'll get 3 back up in a minute if some of you are still jotting some parts down. So what happens if a negative gets thrown in front? That's going to make things a little more interesting. So we'll do one of those. Close my parentheses with the -2. Now let's look at this one first. Ooh, it's opening down. That's what the negative does. The negative that's here makes my graph open down. I didn't do anything wrong. It's still correct. So I'm going to look. Okay, there's my error. Okay, there's my starting point. So I look and I'm like, all right. So it looks like we're starting at 2, 1, 3, -2, 6, -5. Am I going to get the 4th one? I'm going to write down the 11, -8. I can eyeball it. So I'm going to plot those. And it's going to make one thing change a little bit when it comes to my domain and range. When it opens downward, the 2 and the 1 are still going to be involved in my domain and range. My graph, when I start to the left, still starts at 2 and goes off forever to the right. But my range is a little different. Because when I'm doing my range, and I'll pull this back down for a second, range, look bottom to top. Well, here my bottom, my bottom's never going to end. It's going to go down forever. So my range is going to start at -infinity when it opens down. And it's going to come up to its highest y value at that starting point. That's the only thing that can get tricky or change with domain and range. If it opens up, those are always going to be my values. If it opens down, though, that's when I got to start with the -infinity part. Everything else just works when that goes. Any issues? Because again, the worksheet that you're going to work on today, this is getting us into our new homework check here. Basically, it's just going to have you working on naming the shifts and then just using the calculator to find some good points and then do your domain and range with it so we can get some practice. We're going to spend a couple days doing this, and then we're going to grow a little bit more and kind of put one more topic in with it. We'll be done with this unit. Kind of flying through this one. So, issues. All right.